Because it's, I guess, open book, I guess. I don't know what you call it, you guys are doing at home. I'm just going to show you what it looks like so that there are no surprises. So this is what your assignment looks like. Okay, it's at 34. You guys are gonna get a chance the second half of the period to work on it, along with some other stuff from Unit 3. So just typical examples. We've already done these before, solving for A and B. Just getting a remainder, just solving for them. We're doing factor theorem, difference in sum of cubes. I'm just asking what intervals of the graph is a function this below the x-axis. You're just going to graph it. Transformations. Explain why this polynomial function has no real roots. And then your thinking questions, which most of them we've gone through. This is the big one. This is the big sketching one. So I said the location of the x-intercepts, the y-intercepts, the max and mins, and the end behaviors. Okay. So it's pretty straightforward. You guys have up until 11:59 tonight to hand it in. But like I said, you're going to get a chance to do some of it after this lesson is done. And cohort A, you're lucky. So if you have any questions here, you guys can ask me. I'll make the other assignments on Friday so that cohort B can have a chance to ask me questions. But let's see what someone asked. You can write it on line paper, or if you want to print out the pages and write on the pages, that is fine with me. So as long as your line paper answers are organized and you number them like 1, 2, 3, 4, and then like communication, thinking, application, I'm perfectly fine with that. So let's get started with the last lesson of Unit 3. All right, so yesterday we did just linear inequalities. Today we're going to focus on solving polynomial inequalities. So obviously a polynomial inequality is an expression with a degree higher than 1. So for example, we have 5x cubed plus 3x squared minus 6x is less than or equal to 2. And remember from what we said yesterday, we just have to move this thing over and make the right side 0. So it turns into 5x cubed plus 3x squared minus 6x minus 2 is less than or equal to 0. That's what we want to put it as all the time. Okay? So there are some steps when solving polynomial inequalities. So we're going to go through them. A strategy that I like to use when it comes to figuring out where the graph increases and decreases is using the sign chart. I'm sure you guys didn't use it last year, right? Something called a sign chart? No? Okay. So when solving polynomial inequalities, we must first determine the roots. Okay, so we have to either factor it out. Obviously, if it's a degree higher than 2, we're going to have to use factor theorem and then synthetic division to break it down even more. Okay? So we're going to use the inverse operations to rearrange the inequality so that 0 is on one side of it. We're going to factor the inequality and then solve for the x's to determine the real roots. We must consider the sign of the polynomial in each of the intervals created by these roots. We can either label the roots on a number line, or what I like to do is create a sign chart. So when we make a sign chart, we're just plugging in numbers between specific intervals to determine if the graph is positive or negative at between those intervals. And then step 3, we want to state the intervals which satisfy the inequality. So we're going to take a look at an example. So for example 1, we want to solve the inequality x plus 3 times 2x minus 3 is greater than 0 algebraically, and then represent this solution graphically on a number line. Okay? So what are our roots in this case?
3 over
Yep. And 3 over 2. So what a sign chart does is we write the roots down on the left-hand side. So we have x plus 3 and 2x minus 3. And at the bottom, we have the product. So the product is just what you get when you multiply both signs together. So from sign chart, we're going to label from least to greatest. So we're going to start from negative infinity, which is the least number. Then we're going to go to negative 3. Then 3 over 2. And then infinity. So now with the sign chart, what you're going to do is you're going to take a value between negative infinity and negative 3 and sub it in for each of the factors and see what sign it gives you. So someone give me a number between negative infinity and negative 3. 4. Okay. So we're going to plug in negative 4. So negative 4 plus 3, does that give us positive or negative? Negative 4 plus 3 is negative. If I take 2 times negative 4 minus 3, does it give me positive or negative? Negative. And what is a negative times a negative? So that would give us a positive value. So it would be greater than 0 at that interval. Now we take a number between negative 3 and 3 over 2. What would a number be? 1. Okay. So if we sub in 1 for x, 1 plus 3 gives us positive or negative? Okay. If we sub in 1 for 2x minus 3, what does that give us? Positive or negative? Negative. And a negative times a positive gives us a negative. So at this point is when the graph is less than 0. Okay. And last but not least, we have the interval between 3 over 2 and infinity. Pick a number between those. 5. So 5 plus 3 gives us positive. If we sub in 5 for 2x minus 3, still gives us positive. So a positive times a positive gives us a positive. Okay. So if I were to write this in interval notation, how would it look like? Remember, we're looking when the inequality is greater than 0. So where all the products are positive. So it is positive between negative infinity and negative 3. And where else? Mm-hmm. To positive infinity. And now we're going to represent our solution on a number line.
You have to like put an open and close bracket for those ones.
So remember with polynomials, when it hits that vertex or that min point, you're technically not decreasing or increasing, which is why you have that circle bracket. Okay. Or the circle, the circle bracket, because it's just not doing anything. It's just staying there. Okay. But anything before that, it is increasing. Okay. So we have our roots. We have negative 3 over here and 3 over 2 here. So this is an interval notation. How would we write it in set notation? So obviously we have the first step, which is XER, such that what?
X is greater than negative infinity, but less than negative 3.
Or we can just say X is less than negative 3. Or what's the other condition?
X is greater than 3 over 2.
Mm-hmm. X is greater than 3 over 2. Okay. So when we're making this on a number line, are we going to have a closed point or an open point? Open. So open at 3 over 2, and it's going to go to the right of it. And open at negative 3, and it's going to go to the left. Okay? So obviously this is a pretty, I guess, easy example because we didn't have, it was already factored and we didn't have to use synthetic division or factor theorem yet. So obviously, once there's more factors, and once you factor a polynomial with a degree of 5, this side of the charts will obviously have more factors to it. This one only had 2 because our inequality had 2. So for example 2, we want to solve the inequality negative 2x cubed minus 6x squared plus 12x plus 16 is less than or equal to 0. So how can we figure out how to factor this? What's the first thing we're going to use?
Factor theorem.
So we're going to use factor theorem. So we need factors of p. So what are the factors of 16?
Don't you take out the negative 2? Or
Yes, thank you. So we can factor out the negative 2 first. So let's factor out the negative 2. We're left with x cubed plus 3x squared minus 6x minus 8. So now we can use factor theorem. So what are the factors of p, which is negative 8?
1, 2, 4, and 8.
1, 2, 4, and 8. And what are the factors of q? Just 1, right?
Yeah.
So p over q is just gives us back p. So now we need to pick a factor of 8 and sub it into our polynomial equation to figure out which one of those gives us 0. Okay, you guys at home can help too. Which factor gives us 0 in this polynomial equation? F at 2. So f at 2 is equal to 0. So when we sub in 2 for x in that polynomial equation, we get 0. So now what is the next thing we need to do? We're going to use synthetic division. So we have the 2. So remember, we're just focusing on what's inside the bracket. So you have a coefficient of 1, 3, negative 6, and negative 8. So like we learned last unit, you drop the first one. 1 times 2 is 2. Then we get 5, 10, 4, 8, and 0. So what we're left with is f of x. Don't forget the negative 2 from the beginning because we factor that out, and that's going to help us with our sign chart, okay? Because even though negative 2 isn't a factor, it is still a constant that affects the sign of the result of the graph. So we get x squared plus 5x plus 4. And how do we factor that trinomial 5x squared, 4x squared plus 5x plus 4. Okay, so our product is 4, and our sum is 5. So what two numbers give us 4 and add up to 5?
4.
So 4 and 1. So we have 4 times 1 is equal to 4. That's good. And then we have 4 plus 1, which gives us 5, which is what we want. So when we factor this whole thing out, we got negative 2 times x minus 2 times x plus 4 times x plus 1. So now that we've factored everything out, we need to figure out where this polynomial function is less than or equal to 0. Okay? So because we have the less than and equals to sign, we are going to be using square brackets for any number besides positive and negative infinity. Okay? So remember, if you have just the greater than, you're just using the circled brackets. So let's try the sign chart again. But before we do our sign chart, what are our roots in this polynomial equation? X is equal to what?
2, negative 4, negative 1.
Yep. 2, negative 4, negative 1. So now we're going to draw our sign chart out. So we're going to have all our roots on the right side. So we have x minus 2, x plus 4, x plus 1, and don't forget the negative 2, because the negative changes the answer when you multiply everything together. And at the end, we have the product. We need to make a bit of room here.
Sorry, how can you add the, why do you put the negative 2? Just because it's...
So say this gives me positive, positive, negative,
Yeah.
right? But I'm still multiplying by a negative 2. So it still gives us a positive value, right? So that's why the negative 2 has to be there, because even though it's not a factor, it still affects the sign of the result of the equation in the y values. Are you guys done copying this?
Yeah.
And when you're doing the sign chart, you have to put the roots from least to greatest. Okay? So we have negative infinity. Then we have negative 4. Then we have negative 1, 2, and infinity. So we pick a value between negative infinity and negative 4. What number do you guys want to pick? So let's pick, no, pick less than negative 4.
Oh. Negative 6.
Let's do negative 6. So if we plug in negative 6 to all of those x values, what signs do we get? So negative, 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 and 4 negatives multiplied by each other give us positive. So that means the graph is bigger than 0 between negative infinity and negative 4. So now we want to pick a value between negative 4 and negative 1. Which one do you guys want to pick? So let's do negative 2. What do the signs give us when we sub in negative 2 for our x values?
Negative, positive, negative, negative.
And when we multiply negative, positive, negative, negative, what does it give us? Positive or negative?
Negative.
So we get a negative, so that means the graph is less than or equal to 0. So we're going to focus on this. Our next one is between negative 1 and 2. So what value do you want to sub?
0.
So we'll take 0. And this gives us negative, positive, positive, negative, which gives us positive. And last but not least, we have between 2 and infinity. So what number do you want to pick?
3.
So let's pick 3. So we get positive, 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 negative, which gives us negative. So if we were to write this in interval notation, what would our intervals look like? Remember, we want the polynomial equation to be less than or equal to 0.
Open bracket.
Remember, less than or equal to.
Oh, yeah. So it's, we use the XCR.
I'm doing
we're doing
interval.
interval.
Yep.
Just close bracket -4.
Mhm.
And then open bracket -infinity.
Nope. Remember,
Oh, we're going the other one.
we're looking for the negatives.
Oh,
So it's between -4 and -1 is where the graph is less than or equal to 0. So we're gonna get close bracket -4, -1 square bracket in union with what else?
2, close bracket 2,
Mhm.
close bracket infinity.
Remember, infinity can never have a
Oh,
closed
yeah.
bracket because there's no definite value to it. Okay, so our interval notation would be square bracket -4, comma -1, square bracket in union with square bracket 2 to infinity. And if we were to do it in set notation, which Adam was started already, so he said XCR. Such that, what are our conditions?
greater than or equal to -4,
Mhm.
less than or equal to -1,
Mhm.
or greater than or equal to 2.
Perfect. So that's what our set notation would look like. Now, obviously, the last thing I can ask you guys is to graph it on a number line. So let's just try that. So let's graph this polynomial equation on a number line. So our roots we set are -4, -1, and 2. So this is 0, and this is 2. So what would our dots look like on this number line? Are they going to be open or closed?
Close.
Closed. Okay. So close at -1, close at -4, and close at -2. And based on the conditions we set on the interval notation and set notation, how would this look graphically on a number line?
4 and 1 will be like connected.
Yep.
And then 2 goes to the right.
Perfect. And then everything to the right of 2. So do you guys find this sign chart easy to use?
Yeah.
Just a bit tedious because of how long it might get?
Not too bad.
Not terrible. So it all depends on the degree of your polynomial, honestly. You can have more than 3 factors. But I'm not going to make you factor polynomial to the power of 10, because then you'd be doing synthetic division at least 7 times. And I know you guys don't want to do that. So we're going to take the same example, but we're going to switch up the polynomial equation. I'm just going to add a new page. So now we want to take a look at the polynomial inequality of 3x cubed plus 24x squared greater than or equal to negative 48x. So what would our first step be before trying to factor this inequality? So we're going to move the negative 48 over. So you get 3x cubed plus 24x squared plus 48x is greater than or equal to 0. And then what's our next step? We're going to factor out 3x. So we get x squared plus 8x plus 16 is greater than or equal to 0. And obviously, they gave us a good trinomial to factor. We don't have to use synthetic division. So we want to factor x squared plus 8x plus 16. So how can we factor that out? So we're going to do sum and product. So our product is 16, and our sum is 8. What two numbers multiply to 16 and add up to 8?
4 and 4.
So 4 and 4. So we get 4 times 4 is equal to 16. And then we get 4 plus 4 is equal to 8, which is what we want. So we get 3x times x plus 4 times x plus 4 greater than or equal to 0. Is that the way we should leave that expression? Or can we simplify it more?
Plus 4 squared.
Yep. So we're going to get 3x times x plus 4 squared is greater than or equal to 0. So now we are given our roots, which is x is equal to 0 and negative 4. Sorry.
You write x plus 4 twice here for the sign graph?
Yep.
Sure.
For the sign chart, you have to write x plus 4 twice, or you can just put x plus 4 squared and just remember to square that sign after. But for this, I'm going to write it twice. So we get 3x, we have x plus 4, and then our product at the end. So we have negative infinity, negative 4, 0, and positive infinity. So now we need to pick a number between negative infinity and negative 4. So what number do you guys want to pick?
Negative 5.
Negative 5. This gives us a negative. This gives us a negative. This gives us a negative. 3 negatives multiplied by each other give us a negative. Okay? And now we're looking at the next interval, which is between negative 4 and 0. So what is the number between negative 4 and 0? So let's try negative 2.
On the last example, did we not do, like, how come at the end you put positive?
Which one?
Like,
I put positive here.
yeah, I don't know, like, maybe I copied all the last question now, but how can you put positive infinity? Oh, never mind. Yeah.
So we're going to plug in negative 2. So the first one gives us a negative, positive, positive. So what does it give us?
Negative.
Another negative. And now we're going to go between 0 and infinity. So pick a number between 0 and infinity. So 2, so everything gives us positive. So that is where the graph is greater than or equal to 0. So our inequality wants us to figure out when the graph is greater than or equal to 0. So when we write it in interval notation, what is it going to look like?
Close bracket, 0.
Yep.
And open bracket, infinity.
Mm-hmm. And for our set notation, so we have XER to start off with, such that
X is greater than or equal to 0.
Yep. Equal to 0. So as you can see, the previous example, we had to use synthetic division. Some examples you don't, because the trinomial, when you factor out, can be factored out without using synthetic. So it all really depends on the polynomial equation I give you. It can either be a question that takes a long time or a question that takes a short amount of time based off the factoring. So now what we're going to do is we're going to actually see these graphically. So I'm going to have equations that are factored out. So this is going to give you good practice for your assignments. So the next few examples are just about graphing, but before, so when we're graphing polynomial inequalities graphically, so like usual, make one side 0, okay? Factor out the polynomial, and then when you graph it, examine where the graph lies either above the x-axis or below the x-axis. So, or what you can do is graph each side of the inequality as separate functions, determine the intersections of the functions, and then examine the graph to determine the intervals where one function is above or below the other as required. So we are going to do this next example. So as you can see, example A is already factored out for us. So we want to solve each of the following inequalities by graphing. So the first one is easy. We have 4 times 5 minus x times 2x minus 1 times x plus 2 is greater than 0. So before we start graphing, where are my zeros going to be? 5, negative 2, and 1/2, right? Five, negative 2, and 1/2. Now, what is the degree of our polynomial? Does this one have a squared?
Yeah.
Okay, so we'll do the squared. So the degree is 4. Is our leading coefficient positive or negative?
Positive.
Positive, and because it's an even degree positive, what quadrants are we starting from and ending in?
1 to 3 or 2 to 4.
Remember the parabola?
I don't remember.
Oh, it's 2 to 1.
2 to 1. Okay. So what's going to happen when we hit our roots of 5? What's going to happen to the graph at that point? It's going to bounce, okay? So, and then we have to figure out our y-intercept. So if we sub in x is equal to 0, what is our y-intercept?
Oh, no, 200.
So 0, positive or negative?
Positive. Oh, no.
Nope.
Oh, yeah, that's right. So it's negative.
Mm-hmm. Zero and negative 200. So that I'm just going to estimate is all the way down here. And now we can roughly sketch our graph. So we start from quadrant 2 and end in quadrant 1. This is Q2, and this is Q1. So now that we've graphed our polynomial function, now we need to visually look at it and ask, where is this graph greater than 0? Just by looking at it. So obviously, when it's bigger than 0, it's above the x-axis. Okay, so it's going to be above the x-axis from over here. In this section over here, it's above the x-axis. And over here as well.
Isn't it the first one?
Yeah, I know I messed up. It's up until 2.
Yeah.
So let's write it in set notation first. So what's the first interval and where the graph is greater than 0?
X is less than 8. X is less than -2.
Okay. So we have XER. Such that x is less than -2. Where else?
Or greater than 1/2.
But
Less than 5.
And what's the last condition?
X is greater than 5.
X is greater than 5. Remember, because technically at this point over here, it's not doing anything. Okay? The rate of change at that point is 0 because it's just standing still for that split millisecond or whatever time it's there for.
Yeah.
So now that we wrote it in set notation, what would it look like in interval notation? Round brackets or square brackets?
Round.
Round? Okay, what's our first round interval? Two to -2. In union with, what else?
A half and 5.
Half and 5. Which is also in union with, what's the last condition?
5 and 5 and infinity.
5 to infinity. So as you can see, there's multiple ways to figure this out. You can either graph it or factor it and use synthetic and use the sign chart. All right, so we have one more polynomial inequality to graph. So our next example gives us 2x to the 3 plus 3x squared minus 17x minus 12. So what is the first thing that we should always do?
Make it all equal.
We're going to bring the -12 over. So we get 2x cubed plus 3x squared minus 17x plus 12 is less than or equal to 0. Is there anything that we can factor out to simplify it more or no? Nope. So then we're going to have to use factor theorem. So factors of p, we get plus -1, plus -2, plus -3, plus -4, plus -6, and plus -12. And then q, which is our first, is positive -1 and positive -2. And then the next thing we have to do is determine P over Q. So it gives us positive -1, positive -2. Yeah, P, but it also includes what?
A half and 3/2.
Mm-hmm. So now we have to figure out what factor from P over Q, when we sub it in for X, makes that whole function 0.
1.
Okay. So f at 1 gives us 0. So now what do we have to do next? So we're going to be using synthetic division. So we have 1, 2, 3, minus 17, and positive 12. So we bring the 2 down. 2 times 1 is 2. Negative 17 minus plus 5 is negative 12. And we're left with a remainder of 0, which is what we wanted all along. So now what we're left with is f of x is equal to x minus 1 times 2x squared plus 5x minus 12. So how are we going to factor out that trinomial? We're going to use sum and product. So I'm going to go over to this side because I'm running out of room. So we have our product of negative 12 and our sum of 5. So what two numbers give us negative 12 and add up to positive 5? Oh, sorry. Oops. You're right. Thank you, Adam. So it's A times C. So what's our actual product?
24.
Negative 24. And our sum is positive 8.
Positive 5. Positive 5.
Oh, yep. Positive 5. So what two numbers multiply to negative 24 and add up to? I was thinking ahead of the answer, and one of the factors is going to be 8. Yep. 8 times negative 3, negative 24, and 8 plus negative 3 is equal to positive 5, which is what we want. I don't know, I probably told you guys sometimes I think of the answer in my head and then that's what I end up putting on the board. So if you see me doing it again, just tell me and I'm going to fix it right away. So now we're just going to factor by grouping. So we have 2x squared plus 8x minus 3x minus 12. So what's the common factor between 2x squared and 8x? So 2x. So we're left with x plus 4. And what is the common factor between negative 3x and negative 12?
Negative 3.
Minus 3. So we're left with x plus 4, which means when we factor out this whole polynomial equation, we're left with f of x is equal to x minus 1, x plus 4, and 2x minus 3. But because it wants us to graph it out, we also have to remember to do that. So given our factored function, what are the roots for our polynomial equation?
1,
Mm-hmm.
3 over 2, and -4.
-4 and 1.5, right?
Yeah.
Oh, geez, this is going to be super close. Okay, so what is our degree?
3.
What is our leading coefficient?
Positive.
Positive. And from what quadrant does it go to?
3, 1.
So quadrant 3 to quadrant 1. And last but not least, what is going to be our y-intercept?
12.
0 and 12. Okay, so now given that information, we're going to be able to graph this no problem. So we're going from quadrant 3 all the way to quadrant 1. So we're starting here. Tried my best. Okay, so the original inequality stated that we wanted that whole polynomial function to be less than or equal to 0. Okay, so in set notation, where is our function less than or equal to 0? So we have xer such that what?
X is less than or equal to -4.
Mm-hmm.
And x is greater than 1 or less than a half. Less than or equal to.
Mm-hmm. 3 over 2. So x is less than or equal to -4, or x is greater than or equal to 1, but less than or equal to 3 over 2. And in interval notation, how would that look like?
Low is -4, so -30.
Yep. So remember, negative infinity comes first.
Yeah.
In union with what? So what was the second condition in set notation?
1, is it, yeah, they're both close.
Mm-hmm.
And
Yep. I'm not going to start unit 4 today because I want to do both of those lessons together tomorrow. I just want you guys to, because I don't want to throw you off for your assignment today. I don't want you worrying about rational functions just yet. So what we did today was learn about graphing and solving the inequality, and also factoring and solving the inequality. And then we just have one last example. So we have two graphs. We have f of x and g of x. And we want to determine based off the graph where f of x is bigger than the graph g of x. So I'm just going to highlight it a different color so that way you guys don't get confused. So g of x is, or f of x is this graph. So let's just call it the blue graph. And g of x is the green graph. So where is f of x greater than g of x?
X is greater than -1 or less than 3.
Okay, so this is in set notation. So we have XER such that X is greater than 1, but less than 3. Is it 1 or negative 1?
Oh, negative 1.
Negative
Did I say
1.
1? Oh.
Yeah. All right, and if we were to write it in interval notation, how would that look like?
Open bracket, -1. Open bracket 3.
Yep. And just for the sake of knowledge, we have our number line. We have -1 here and 3 over here. How would it look like on our number line? Open or closed circles?
Open.
Open, and then it's just the intersection in the middle. Right. So there's a couple things you guys can do. You guys can either, well, cohort A, you have the advantage. Either start the assignment. If you guys have any questions, you guys can ask me right now. Cohort B and C, you guys can start on the assignment as well. I'll stay logged on the meets if you have any questions. Or you can work on the 3.2 and 3.3 extra practice on Google Classroom, or work on the chapter review for Unit 3. So you have 3 things to do. That's more than enough work for the next hour and a bit. So cohort A, I would suggest just doing the assignment, and if you have any trouble, just ask me the question. Oh, I don't take attendance questions for these classes in the morning. I just do it for the afternoon. So like I said, cohort B and C, you guys can either work on the assignment, 3.2, 3.3 extra practice, or the